This presentation covers Chapter 2, the Kinetic Particle Theory of Matter, IGCSE Class 9 and 10 Chemistry Curriculum. In a solid, the particles are closely packed and arranged in a regular structure. The intermolecular bonds are very strong. In a liquid, the particles are slightly less close packed, and there is some structure. The intermolecular bonds are strong. In a gas, the particles are spread out. The intermolecular bonds are weak. As particles gain energy, they can either increase their kinetic energy and vibrate more, which changes their temperature, or they can break their intermolecular bonds, which changes their state. Introduction to Kinetic Particle Theory. Here are the key concepts. All matter is made of tiny particles, which can be atoms, molecules, or ions. These particles are constantly moving. The theory explains the states of matter, expansion, diffusion, and changes of state. This theory is based on experimental observations and the behavior of particles at different temperatures and pressures. This slide shows a model of a chrome alum crystal and reviews the arrangement of particles. In a solid, particles only vibrate about fixed positions and have a regular structure. In a liquid, particles have some freedom and can move around each other, colliding often. In a gas, particles move freely and at random in all the space available, colliding less often than in a liquid. Core assumptions of the kinetic particle theory. Matter is made of tiny particles. Particles are in constant random motion. As temperature increases, particles move faster. At the same temperature, heavier particles move more slowly. An important piece of evidence for particle movement is diffusion. Diffusion is the movement of particles from a region of high concentration to a region of low concentration. It occurs faster in gases than in liquids because there are larger spaces between the particles. Particle arrangement in different states. Let's compare the properties. For particle arrangement, solids are fixed and regular. Liquids are close but irregular. Gases are far apart and random. For motion, particles in a solid only vibrate. In a liquid, they move around each other. In a gas, they show rapid, free movement. For energy level, solids have a low energy level. Liquids have a medium energy level. Gases have a high energy level. For compressibility, solids are not compressible, liquids are slightly compressible, gases are highly compressible. For forces between particles, these forces are strong in solids, moderate in liquids, and negligible in gases. Temperature and pressure effects on gases. A higher temperature means particles move faster, which leads to a greater volume or pressure. Increased pressure at a constant temperature means particles are compressed, which causes the volume to decrease. Here are some real-world examples. If you heat a balloon, it expands as the gas volume increases. If you cool a balloon, it contracts as the gas volume decreases. When you pressurize a container with a pump, the gas particles get closer and the temperature increases. Changes of state and energy transfer. The change from solid to liquid is called melting. This process absorbs energy. An example is ice turning to water. The change from liquid to gas is called boiling or evaporation. This process absorbs energy. An example is water turning to steam. The change from gas to liquid is called condensation. This process releases energy. An example is steam turning to water. The change from liquid to solid is called freezing. This process releases energy. An example is water turning to ice. The change from solid to gas is called sublimation. This process absorbs energy. An example is dry ice turning to carbon dioxide gas. Summary: why the kinetic particle theory is important. The theory is important because it explains the behavior of solids, liquids, and gases, accounts for changes of state, expansion, and diffusion, links the energy of particles to temperature and pressure, is useful in understanding daily phenomena like balloon inflation or cooking smells. The slide shows an illustration of gas molecules moving randomly in a container, reminding us that particles of matter are always in motion. Thank you for learning with us.